In this video, I'm going to show you how you can set up your double integration. So let's say you've got a surface. So this is your surface, and we are trying to work out the volume underneath this surface in this region. So so this is 2 here. So the origin's here. So this is your 2, and this length here is 6. Just imagine this to be 6. So we are trying to work out the volume underneath this surface. So there are two ways of doing this. Dx by dy or dy by dx. Both will lead you to the same answer, but sometimes one is easier than the other, and as your experience build up, you will develop the gut instinct on which one to use, dx by dy or dy by dx. This will happen over time. So for the time being, let's randomly select this one. When you first meet double integration, it's hard to visualize what's going on. For example, do you put from 0 to 2 here, or do you put from 0 to 2 here? It's confusing when you first meet double integration. So whenever when you first meet double integration, imagine this as this. So this is going back to Riemann's summation, and then imagine this as this. So to really understand what's going on, when you first meet this, it's confusing. So imagine this as this. So let's just try and understand what's going on here. So when you see this, this is like this, just like it is here. So imagine, let's just say I is 1 here, J is 1 here. So when J is 1, hang on, you've got one block here. When J is 1, in your mind, cut this up into millions of pieces. So in your mind, cut up into millions of pieces. So just imagine lots of small grids. So now when this here is 1, J is 1. So when J is 1, you can see that's the Y is fixed. So J is 1 here. So this is J, and then I gets incremented and cycles around. So it moves. So the first one will be you working out the volume of this box, and then this box. So you can see it's moving in the x direction. It's moving in the x direction. So when all the ones are done, then J gets incremented to 2. So now J is at 2. So now it was, and then this will cycle around again, and then you can see it's moving in the x direction. So whenever you see this, it is really you moving in the x direction. So just bear in mind, when you set this up, it is moving in the x direction. Now let's look at dy by dx. So looking at dy by dx, so imagine this as like within brackets. So let's just say this is I1 and J1. So here J is fixed at 1, and then this loops around. So J is fixed at 1, meaning your x is fixed at 1. So this is 1 here, and then the I gets looped around like this. So you're moving in the y direction. So what's happening here is you summing up this volume, and then this loops around, meaning you're moving upwards like this. You're moving upwards, and when all this is done, J gets incremented by 1. So now J is 2, but J is referring to your x. So this is 2 here, and then it cycles around again in here. But then what's cycling is the y. So you're actually moving up like this, and then all that's done, this gets incremented again, equals 3. So 3 would be here, and then this side loops around, so it's moving up like this. So you can see it's moving in the y direction. It's moving in the y direction. So when you see this in your mind, picture this. In your mind, picture your domain x, y. Look at this bit here. This is really you moving in the y direction. So it's always parallel to your y axis. Looking at this thing, in your mind, picture the domain x, y, and then because x is on the inside, it is moving parallel to the x direction. Okay, so if you get confused, imagine this thing here and then slowly build it up. So this is moving like this, and for this scenario it is moving like this. It's summing up everything here in this manner for this one. And then for this one here, because x is on the inside, it's moving around like this. Anyway, let's work out the volume. So I will continue in the next video. Okay.